Today we're going to be looking at and discussing the GIS MSAG Alley Data Analysis that we've been working on the last couple months. And we're going to go right into an overview of sort of what they are and what we've done, looking at some of the data that you, the locality, have provided us at state level. We're going to go through the components of the analysis. So what we're going to do is we're going to talk briefly about what each component of each analysis is from the GIS analysis perspective, from the MSAG and the Alley perspective. And then after we go through the components, what I want to do is take a deeper dive and look at actually the data. So from that perspective, we're grateful for Roanoke County giving us the ability to utilize their data results. So we want to give them a big thank you for that. And we're going to use their results as we go through it. But you as a locality can look at what we are going to present and kind of put yourself in the position of the editing position on the base of the data that we have. So we'll take a look at those individually as we go through them, and then we'll wrap things up hopefully pretty early in time for you to ask questions. So without further ado, I'm going to hop right on in, and we're going to talk about the analysis. So first things first, we want to talk about what the current status of 911 in Virginia and across the United States as a whole. So local government enhanced 911 is currently driven by the MSAG and the Alley databases from Verizon, CenturyLink, Comcast, small telcos, and other third parties. So that's the current status of 911 throughout anywhere. So that acronym MSAG, what does that mean? So the MSAG is actually the Master Street Address Guide. And what essentially it is streets with a range for the county, and that's represented by the provider. So that's MSAG, or that's Verizon, that's CenturyLink, that's Comcast, Verizon. What you have in your locality for all the streets and the ranges that are within that. And it also includes some community information, some ESN information, and things of that as well. The Alley, on the other hand, are all the addresses with wireline phones that reside along the MSAG. So you're thinking about like a tree, the branches of the tree would be the MSAG, and then the alley would be the buds of the tree, representing the individual addresses as they are present from that provider. So from a wireline perspective, any subscriber they would have an alley record for them. The MSAG and the alley are highly synchronized. So at this point in time, from a state perspective, we've been able to look through essentially every MSAG and every alley for each locality, and we're finding that the synchronization is extremely there. But what the MSAG and alley are not are geospatial data. So within a dispatch system, the MSAG, the alley, and the GIS, even though they still work together, they are somewhat independent, but they do work for call routing purposes. So knowing where we are currently with that data and then where we're going with NG911, NG911, the MSAG and the alley are being replaced completely with geospatial data. So the road center line is essentially going to replace the MSAG. Thinking about ranges, thinking about zone information, thinking about street names, the MSAG is going to go away. And from an address point perspective, that's going to replace the alley. So anything that you would see in NG911 is going to be, from the address perspective, is going to be replaced by the address points. So what does that mean for you, the locality? And you've heard it a lot with NG911 coming up, but it is imperative for local data to be clean. And it's also very imperative for local data to be synchronized. So this effect that we get data from localities and we take local government data, apply it to statewide databases, it will impact essentially all levels of government within the Commonwealth because of the visibility and use of this data and why it's going to be used in NG911. So why are we doing these analyses? So really looking at it from a current, future, and geospatial standard perspective. So we're looking at these analyses and performing these analyses for your data to support where 911 is in its current state. So where GIS data is not synchronized with the MSAG and the alley. So where your road center lines are not synchronized with the Verizon, Comcast, CenturyLink, MSAG, and also where your alley records are not matching up to the Verizon, Comcast, CenturyLink records as well. So what we're doing is we're able to check and see in its current status how synchronized System A is, System B is, and System A, B, and C are together. Also looking at it from an NG911 perspective, these analysis support NG911 from this perspective of we're taking your GIS data and we're doing a GIS analysis, and we're going to be able to check synchronization between your address point and your road center line, looking at things like street names, looking at address ranges, looking at how well the road center line meets certain topological recommendations, standards, and best practices. And then looking at the analyses, how they support GIS, Geospatial Data Standard. So how compliant is your local data to the state RCL data standard? How compliant is it to the NENA, the USPS, things that we at the state level have utilized in our state data standards. So a general overview of the history, kind of where we've come and where we're going with these analyses. In 2015, we had a goal of doing about 30 of these localities throughout the Commonwealth. The idea was localities would send us their base map data as they were already submitting it to us from a formal data submission perspective. And also, the locality would have to go after the MSAG and the ALI from their provider. So there was a little bit of legwork that had to be done for us to do these analyses up front. And then we would provide that in turn back to the localities after the base map was provided to us. So what we found from those 30 that we did, the results were, it was a good snapshot, but it was somewhat inconclusive. So as we started looking at localities, some localities had a really good GIS analysis, and other localities had a really good MSAG-ALI analysis. But in some cases, they just didn't translate across the board. So we found that by looking at it from a statewide perspective, we would have the ability to really stack up and see current status of geospatial data quality throughout the Commonwealth for the address point and for the road center line. So in 2016, as the year began, the road center line data standard that VGen had worked on for several months was approved. And what that meant was that we could basically take data as it's provided to us from the localities, and we could check that data against the RCL data standard and provide that back to the locality as a courtesy. Also, with that, statewide MSAG and ALI databases were received by VGen from CenturyLink and Verizon. So we had a lot of data in hand and the ability to utilize it. So we began these analyses summer of 2016, a few months ago, and we are in the process of distributing those results back to the localities. What it will ultimately provide for us will be a T0 for data quality. So we can actually look at the data that's been submitted to us, and then as we get GIS data submitted to us in the next couple months, we'll be able to look at it from a baseline perspective of how did data change through time and how will it change through time from a data quality perspective as localities submit us their database. So what these results look like to you, the locality, and to anyone who would be maintaining this data for a locality. It's essentially a data package, and that comes back to the locality for each type of analysis. So for the GIS analysis, for the MSAG analysis, for the ALI analysis, we're able to give back a zip file. Within that zip file, there's a file geodatabase that's zipped up, and that's in ArcGIS 9.3. There's a layer file, and that comes back to the localities at ArcGIS 10.2.1. We actually found in the last week or two, a locality was looking at the layer files that we included, and there was a backwards compatibility issue with older software. So just as you all know, this information that we give to the localities, layer files are in 10.2.1, but we have 9.3 available. We've exported them out as well, should you have any software before 10.2.1. Also, we've given back an analysis report within a PDF that goes back as a nice presentation piece to the analysis. So the GIS analysis, it reflects the VGen RCL data standard rules and how the data from the locals stack up against those rules that we have generated in the state RCL data standard. So this is somewhat of a courtesy from us to localities to say, we have a standard, how well is your data standardized to that standard from a QC perspective? And then these results, they actually will use the locality's geometry and attributes. So when you get your results returned back to you, the GIS analysis is using the VGen schema, but it's actually using the locality's geometry and it's using the locality attributes. And that's important to know because you can know that when you look at these results, you're actually looking at the data that you've submitted to VGen with your formal data request submittal. The results are prepared for locality review, and then the corrections that are within those that are necessary will be made or flagged via an exceptions layer. So we've also created a point feature class that the locality can take and essentially drop a point into the map where they feel there is not an inconsistency. But we reported to them as an inconsistency, which is not necessarily a true error, where it's just one of those things that occur in data and legacy systems. So we want to go ahead and look at the GIS data analysis and really what it's made up of. And then once we go through that, we'll dig in and we'll look at some of the specific results that come back with the GIS data analysis as we send these to the localities. So how they're created. So what we do when we generate these GIS data analyses is we utilize ESRI Model Builder. We also use a little bit of scripting from this, but for the most part, we use models that work with other models in a string. These rely heavily on the ESRI Data Reviewer extension. ESRI Data Reviewer allows you to go a little bit beyond the basic out-of-the-box topology. It allows you to customize and configure checks to data sets from a batch perspective. Also, GIS data quality checks that we return to localities. 17 of these are RCL data checks, and these are based on the RCL data standard as mentioned, and then 4 additional checks that we're looking at from the address points. They check standards and best practices that are existing. So really, some of these address point checks that we're running, and we'll see here in just a moment as we look at the data, those address point checks actually rely heavily on the address ranges that are within the road center line or the road name within the road center line. They kind of work together. So so sometimes when address point data checks yield an inconsistency, that will require a road center line alteration. And then we are also reporting back to the locality a fishbone data set. What's a fishbone data set? We'll take a look at that in just a moment, and we'll explain to you what it is. It's a really handy tool that helps you visualize your address points from a straight line diagram from your point to interpolated point along the line. And then checks for attribute and geometry inconsistencies are within these analyses. So we're not just giving you one or the other. We're actually going to give both. So we're not looking at just where you got address errors. We're also going to look at some of the geometry topological inconsistencies that occur as well within the data. And this is what the PDF that we return back to you will look like. Just imagine this slide populated with the results that you provide to us. Many of you have already seen these results, so you're familiar with what it looks like, but this is just an idea to let you know when you get a data set back from us, it's fully populated. Ideally, it would be nice to see it exactly like this coming back to you with zeros across the board, but we understand in our current status that's just not where we are. But we can have goals and aspirations. So let's take a look at some data. I'm going to log into a server here, and we're going to have a look at what these results look like. And first off, we're going to just look at the RCL geospatial GIS analysis results. I'm going to flip off everything but that, and we'll have a look. So you zoom into one of the first sections that we were talking about when we were looking at the data. So what you see here on the map is a fishbone map. So what a fishbone map is basically where the address point is, and its interpolated point along the line is pieced. It's a straight line diagram from the point to where the interpolated point is along the line. Now, again, I want to say thanks to Roanoke County for letting us use their GIS data and their results. And one thing to note about their data is if you were to look at the ranges that are within this address or within this center line, they use 100 block ranges. So, for example, we can see on the points 3602, 3608, 3614, all the way up to 3644 on the left. 3601 all the way to 3645 on the right. Well, what this means is they're even is on the left and odd is on the right based on the direction of travel from this center line, as you can see it moving through here. Well, they use 100 block ranges, so what that means is they're starting left here at 3600 and they're ending at 3698. On the right, they're starting at 3601 and they're ending at 3699. So if you think about blocks from that perspective, addresses end up becoming a percentage. So a straight line diagram will essentially be the percentage in that block. So a perfect example would be 3645 and a 100 block range. That's going to be 45% along the line. And you can verify that by seeing where the match is. It's about 45% along the line on the fishbone. So that's what Fishbone Navigator is going to do for you. It's going to let you visualize where your points will actually end up landing if you were to interpolate or geocode that point, where it's going to look like on your road center line. And with that comes intersection. So fishbone lines should have straight lines and shouldn't necessarily intersect any other lines. But what we've done with one of the layer files that we've included is we have included an intersection symbology. So you can see based on dark red, they've got more intersections. So that will allow you to go in and basically see where you may need to either readdress or put emphasis on those addresses that are within the data. So I'm going to go on to the next. We're going to look at unmatched address points for road center lines. So this is one of those checks that we run that's very important, and it's critical for matching your points to your center lines. So in the case of this road here, it looks like we have half of them matched to the road center line, the other half are not matched. And you could ask yourself, well, what's going on here? So first thing, we can look at the address points and we can see. Okay, so on the right-hand side, they're starting at 5400 and they're ending at 5426. And then on the left, it's 5401 and 5425. So it looks like from the road center line perspective, the arc is headed the appropriate direction based on the endpoint. Well, something must be going on here if these are not matched. So if you do an identify on it, you can see left-hand side of the road, 5401, 5499. Everything looks great. On the right-hand side of the road, they have been duplicated in the ranges. So what it appears that have happened is this just needs to be altered in order to make these roads, these address points fit into the road range. So in the case of this, if we're going to keep consistency of even and odd, looking at the address points, it's even on the left, or odd on the left, even on the right, you would want to make these right-hand side of the road changes to the even. So this will be a 5400 and 5498. So very straightforward. When these are flagged and presented, most of these are self-explanatory, and as you see them, you can make alterations as you see. We'll look at one more. We'll look at address point street names where they're not matching the road center line. So in the case of this one here, you can see in the layer file that we return with the GIS analysis, you can see the exclamation points here in blue. What they come up as are where these address points do not match the street name in the address point with the street name in the road center line. So if I do an identify on one of these points, I can see this road right here, the inconsistency is returned in that field. But the address point is actually calling it two-ford, TWO spelled out, while the RCL is actually referring to it as number 2, Ford Road. So you can see there is definitely a difference in the address point street name and the road center line street name. And this would be like looking at a MSAG and an alley and one having a different name than the other, even though they're supposed to be in the same neighborhood. And that would be a very critical piece to have synchronized. In this case, there's a dysynchronization in between these two. And you can just scroll around and see where exactly these occur. In fact, we can actually scroll around to somewhere in the area and just see other area results that are showing up within blue like this. I'll just zoom in on this one and you can see. We'll identify on it and see what's going on. So this address point is calling it Brambleton AV. That's not, the AV is not the USPS NINA standard for that suffix. RCL is calling it Brambleton Avenue, which actually is the USPS and stuff. So it's just a differentiation in between the two. Now I will zoom out just a little bit, and you can see there's a few more in this area that occur. We'll do identify on this one as well, and we'll see the difference. So same idea, AV versus AVE in this treatment. So these are going to be important. These are going to be ones that you'll see, and when they come up, they'll make total sense to you, and you can make adjustments as need be. Another part of the GIS analysis is going to be very critical is where duplicate address ranges occur. So in the case of this one, if I do an identify on this road segment, you'll see we've flagged this one and returned it back to the locality saying, by the way, there is a road center line address range duplicate. So in the case of this one, you can see based on this road name, Flintlock Road, there is a left from 5100 to left to 5198, right from 5101, right to 5199 in this segment. Well, if I do identify on this segment here, I get identical attributes. So 5100, 5198, 5101. So we flag these as two areas that need to be looked at from a local perspective. Now, this is nice because you can actually look and see on the imagery, this house has a driveway off of this section of Flintlock, but it's being geocoded right here because there are duplicate address ranges that are within these two segments. So it's important to make these corrections from that perspective. Also, if you look at the actual points themselves, you see 5100, the flow of the road actually travels this direction. So there needs to be a little bit of an alteration in the address range. And in this case, you have a direction of travel flag as well, which we'll show. And in this area, you know, it's one of the issues that you're probably dealing with a couple hundred feet or maybe 1,000 or 2 feet. But when you're looking at a rural area and there are miles and miles of roads and there's duplicate address ranges, it's extremely critical to have those cleaned up and checked out for geocoding purposes alone. Okay, we're going to go on to another check that we have put into the GIS analysis. And this one is called address side. So looking at the points, I'll turn off the labels as you can see. These sort of stick out in certain areas. We've been told in some cases these are flagging address points that aren't necessarily on the wrong side of the road, and that's true. We've actually looked at a few of those, and there are, in some cases, address points that are not true errors. There are inconsistencies, but they're not true errors. So what we've done with this is we've isolated these, and we want these to be looked at in batch. So in the case of a road segment where every single address is flagged with a side issue, that's going to be a segment of interest. So in the case of this, I'll turn on the address or road labels for this specific road, and you can see this is Cedar Lane, left-hand side of the road, 3600 to 3634, right, 3601, 3635. So it looks fine. From a fishbone perspective, you've got your directionality correct on the center line. You've got your lines drawn from the point to the interpolated point of the line in pretty good shape. So it looks fine. It doesn't look like anything is wrong here. The thing that these side point reveal is where, in fact, your direction is from an address low, high, left, right perspective. So as soon as I turn it on, you can see on the left-hand side of the street, based on arc directionality, 3603 all the way down to 3633 on the left, 3604 all the way to 3634 on the right. So in theory, even is on the right, odd is on the left, based on the direction of travel. But if you look at the actual ranges that are within the center line, left is on, even is on the left, odd is on the right. So they've got them flipped. It's just a matter of making corrections to this data on the road center line. And the nice thing about it is if you actually do the counts, you're looking at 10 to 15 individual points here that are yielded as an inconsistency. But if you essentially make 4 changes to your data in the address ranges, you've cleaned up all 15 of those inconsistencies that are returned to you. So that's another thing. Even looking at the unmatched geocoding results, you can get a lot of bang for your buck all it requires is minimal changes to your data. That's what we really want to emphasize here. We'll go to one more, and that's going to be the arc directionality. So as we're talking about the fishbone and what it can do for the localities, it's really nice when you start looking at things like arc directionality. And the MENA and USPS standard and the region state RCL data standard says that addresses will flow from low to high along a road. So what that means is the arc directionality needs to begin at the low address and then face towards the high address. So in the case of this, you can see on the left-hand side of the road, 7304 on the top, 7340 on the right. That's going to be your even side, and 7309, 7345, that's going to be your odd side. So just theoretically, your left-hand side of the road is going to be even, and your right-hand side of the road is going to be odd, just looking at points alone. So you can see the fishbone has actually yielded a incorrect directionality result based on the point, and has revealed a whole bunch of these little crisscross here intersection sections here. So that's the benefit of having the fishbone map, is it can reveal these type of inconsistencies as well with your data. And in this case, it's a matter of flipping the data, or flipping the arc, and you'll also see these are coming up as side inconsistency issues as well. Well, if you flip the arc, it's going to correct that as well, because assuming your ranges are staying the same, your evens are on the left, your odds on the right, but it's going to remain consistent when you actually have results. I'm going to go back over to the presentation, and we'll just talk quickly about several data recommendations. So as we looked at all of these are things that when you get your GIS data analysis results, have a look at these. And these are based on critical items, as we mentioned. But first, take a look at your unmatched geocoding results. See what it will require in order for you to fix whatever they have been located. Take a look at your road, turn line, street name, and your address point street name mismatch. Make changes to those as you can, knowing the use of this in NG901, how it will essentially be an MSAG alley street mismatch, or at least compared to that within the current generation. And then look at your address range overlaps, and then your duplicate address range, just like we looked at. Line topology issues, directionality, and other things that are needed. And then sort of the bottom of this is the visual fishbone address range issues. These are things that you'll want to really have a look at in your data to make sure that they are synchronized moving forward. Well, I'm going to move on to the provider data section, and we'll talk about what we're doing with your data when we're comparing it to the provider data and these analyses that we're doing with that. So keep on moving along, and we'll hopefully go through these and then do another showing of what the data looks like and how ArcGIS is showing this information. So with these provider data analyses, we are taking the MSAG database from the provider, and we are comparing your road center line to it. What we're doing is we're basically creating or using a dissolved geoproximity command, taking your high left right, your low left right, and we're using that as statistical information to provide this dissolve. And then from there, taking that table, applying that information, comparing the geospatial data to the non-spatial data, non-spatially. So we're comparing the provider MSAG directly to your RCL, and we're able to report that back to you via the RCL. Yeah. Also, on the ALI database side, we call this the most critical part of the analysis because we're basically looking at all of the waterline addresses from the provider and how they match up to your current GIS data, whether it be your address points or your road center lines. And so the matches will actually go to the provider address. They will go to the GIS data. And this actually will note whether the match is to the RCL, to the address point, or didn't match at all. The ultimate goal is for all the ALI records to match an address point, and that means either one of the components is needed to be changed or other. And that may require that the ALI needs to have updates to it based on these analyses. So If there are indeed addresses that are within the alley, that there are no match at all and there's no geospatial data, and field work has verified that there is no change or anything necessary, then the alley will need to be corrected as needed. So these data analyses, they also look for other data quality issues. So as we're talking about synchronization from the local GIS data to the provider data, we're looking at it from a systematic perspective. So how synchronized is your data when looking at geospatial to the MSAG to the alley? And that kind of works together as it would be within your CAD system. It's critical that these two errors that are true within the GIS data or within the provider data are made changed. And then the need for this is for the data to reflect reality. So that's why we have the GIS spatial data standards, the RCO data standards, address point data standard that's in development. Some of these other things that we have, that's why it's very critical to use those when presenting this data back to you, so you can then have your data look more like what it is out in the field. The ultimate goal is all the callers that are calling 911 currently with a wireline, landline phone can be located. And that's done by the analyses that we are performing for the locality. And then, as mentioned earlier in the historical portion, where we are looking at, from our perspective, how determine the amount of investment goes back to GIS. What's it going to look like once we're done looking at these provider analyses? So let's go right back to the GIS. Let's have a look at our GIS again, and we're going to pull up MSAG and alley analyses and how these can be used by you locally. I'm going to pull in this section here, and we'll go over to one section of the county. So looking at the MSAG analysis, so as mentioned, the MSAG is basically the provider's representation of a road within your county. So thinking in terms of if you had 10 roads with the same road name, of those 10, you're going to have essentially 2 road segments that have a high and a low. So you're going to have one segment with a high and one segment with a low, even though the NENA standard is left from left to, right from right to. Thinking in terms of a flattened, dissolved piece, you're going to have a high and a low with the road name. So that's what the MSAG is doing. The MSAG is storing it that way, and we're taking the geospatial data, flattening it out a little bit, and we're comparing it to the provider data. So along the lines of this section, what you can see is the MSAG data is going to report where there's a high and there's a low in the GIS data and in the provider data. And what we've been able to do here is we've been able to flag where there is a difference between the two. So in the case of this segment here, you can look at the road center line is from 5100 to 5199. The MSAG is 5100 and 5152. So on the high side of the MSAG, there is a difference between the two. Now, as we're talking about geospatial data updates and fishbone mapping and things of that nature from the geospatial perspective, well, if you make alterations to a high or a low piece in a chain of roads, you could potentially be taking your data out of sync with the MSAG. So we understand that, and that's why we feel that the results that show whether or not that road center line matched to the MSAG or not is the most critical piece to this. So thinking in terms of did the road center lines that you have in your data match to the provider MSAG, yes or no? And if no, why not? Well, what we've been able to do with the MSAG analysis is return to you where these are residing in your data. So in the case of this section that I've moved to, I'll show exactly what we're showing. So these red, according to our symbology, anything that you would see in red is going to be something that is not matched to the MSAG from the road center line. And anything that's colored with blue or purple or pink or yellow, that means it did match, but there's a varying degree of difference between the data as it did or did not match. Whether or not the low was different, whether or not the high was different, whether or not the high and low was different, or whether it was or not it was identical on the high and low. But in the case of the unmatched, that's what we really want to look at. So I'll look at this segment right here, and we'll see what's going on with it. So this segment of road is called North Lake Drive. If you scroll up just a little bit, you'll see. So on the high and the low, North Lake Drive is the name of this road. One of the checks that we've put in the alley analysis, which we'll go into in just a second, but it is where the alley geocoded to the address point, or it's geocoded to the road center line, but the street name is different between the geospatial feature and the alley record. As we know, alley and MSAG are supposed to be and are currently in Virginia highly synchronized, so we can assume that the community and the street name are synchronized between the two, and we can look at this piece of data together and see why it's not why it is not creating a match in the MSAG. Easy way to do it is to utilize this alley street name is not equal to the road center line, do an identify, and you'll see. Just like in our road center line is not equal to address point center line street name, you'll see in this one that there are two different street names. So the alley is calling it In Lake Drive. RCL is North Lake Drive, as we saw earlier. Well, so that's why it's not matching up. That's why this road is not matching to the MSAG, is because MSAG in the alley are calling it In Space Lake Space Drive. Lake Drive would be the street name according to the alley. It has a prefix direction and it has a street type, but according to the county, there is no prefix direction. The street name is North Lake. So we can just pull up the MSAG unmatched result and see. We can look for that in Lake and see, okay, is that what's going on here? And just lo and behold, we can find that that's exactly what's going on with the MSAG. Is it's basically named different than what is named in the local GIS data. So there's going to be a reconciliation process that would need to take place. In the case of this one, either the provider would need to be contacted with the actual street name, or the locality would need to make some alterations to the data and utilize some of the standards in place. Could be one of two. But the point is, we've flagged these and provided them back to your locality so you can have that as a resource when going back to the locality or going back to the provider. So that's what we want to show. Is we want to show that the MSAG analysis, the most important piece of this is where your center lines did not match up. It's all listed in tables. It's in geospatial data, so you can actually see where indeed this is not valid. Another part of the provider analysis that we've done is we have looked at the alley. So I want to zoom over to this one section of Roanoke County. This is Hollins University. I want to turn on the alley analysis results that we provided back. And as mentioned in one of the slides, the ultimate goal here is to make sure that all the alley records match a address point record. So in the case of this section here, there was a match with this Hollins University address, but it was not matched to the road to the address point. It was only matched to the road center line. So what we can do is we can pull up this database where the addresses match to the road center line, but not to the address point, and we can see exactly what's in there. We can see what's going on with this data. I did this beforehand, but you can see there are 1,321 alley records that match to the road center line that did not match the address point with this Hollins University name. What it's trying to do is it's trying to match 7916 to the data. So what you would probably want to do is take these results and go back to the provider and see why they're not using a different address, or look at your GIS data and see what's going on with 7916 in this case. If you turn it on, you can see the imagery, there's not really any address points or anything that would be addressable along this segment of road, so you could probably conclude that it is something within the alley database. But again, that's going to be a resource for you to use and take back to your provider. Or in this case, we know that it did match to the road center line. So if someone from that address did call 911, it may not have matched to the point, but it would have matched to the center line. So that's a good thing to know. Another thing that we'll look at within the alley results is where there is a difference in between community information. So with the MSAG, a lot of times you'll see in an MSAG, there's going to be a record for one segment of street or segments of street with a range, and they'll have one community, while there may be another entry into that MSAG database with a separate community using the same range. We found in some cases that causes a mismatched result. So if I were to go in and pull up these unmatched results, and I did a sort based on this information, I'll just do a quick query to locate two of these. And this table that I'm looking at here, this is all the unmatched alley records to the GIS data from the county. So this is looking at anything that didn't match to the road center line or anything that didn't match to the address point. And these are two of interest that I was looking at earlier. I wanted to see what was going on with these. So if I did a query on Green Ridge Court, we'll do a sort and we'll just go down to it and see what's going on. Well, what's going on here, if I zoom into this area, there are several matches already in this area, and you can see there's matches in blue. These are using the symbology for the alley analysis for we returned for residents. Well, in the case of this symbology, you can see there's a result here for this address, and it's using the community of Roanoke. Same with this one, using the community of Roanoke. That's not a problem when you're talking about a zone, because you can essentially say, okay, we have a zone here, we have a polygon, anything within that polygon that's going to fall within that zone is going to match. It's going to create a match to either the address point or to the road center line. Well, in the case of these two addresses, if you actually scroll to the right, it's using the community Holland, so it didn't match up to the Roanoke community. And the reason why is because in the MSAG, there's a record for Hollands using Green Ridge Court. There's a record for Roanoke using Green Ridge Court. And in the case of this alley, it subsequently used the Hollands community to match up. So when taking the data and trying to apply it to the GIS data using a zone, it becomes problematic when you have incorrect community information. Another thing that we've also found when looking at some of these alley analysis results is there are, in many cases, records that are included within a specific county that are not within the county. So in the case of this, these 7 records that I have highlighted here, Hidden Valley School Road, you can see these are Roanoke County of, not sure what it is, but that's who's included as the customer name. But this Hidden Valley School Road is actually several miles within the city of Salem. So there have been records included in the alley, and there would have to be an MSAG record created to this to match in the MSAG that are not going to match geospatial data just because of location. So these are of interest. These are things that we know about, and these are things that we may look at after the statewide release and try to do some more regional matching of this data and see how well these results are. So looking at this data, there were 30 records that didn't match the GIS data at all, but if we know that 7 of them are outside of the county, and then there are several more that can't match because there's no relationship to the MSAG, then we can even trim down that unmatched total even more. So just little things like that we're looking at in the data, and you can look at in the data as well to essentially see where there are differences between what you got in your geospatial data and what the providers are referring to in their data. All right, so making a recommendation based on looking at this, 2 really straightforward things that we've looked at. First off, in the MSAG, where is the MSAG not matching the RCL? How to look at those, see where they are, where they reside, and why they're not matching up. Again, you can take that alley results, alley analysis result, include that in a map in MXD, overlay it within the unmatched results for the MSAG, and you'll see them kind of come alive. In the case of that one that was North Lake, you know, it was just an issue of the road spelling or the standardization. Also, from an alley unmatch perspective, have a look at your address points. Have a look at the alley results that did not match to the address points. Take a look at them, see why they didn't match up. In the case of Holland, we may find that that address just needs work in one of the feature classes, or it just needs to be altered in the alley. So have a look at where it didn't match the address point, and then of course have a look at the alley unmatch where it did not match GIS data at all. And these are going to be the two critical items when reviewing the results. While there may be other uses for the alley analyses, these are going to be the two big recommendations when it comes to the data. So I want to conclude here. I want to wrap things up after talking about these analyses, after looking at some of the GIS MSAG alley individual locations within the geospatial results. We'll just kind of close it up and just talk about things that are either upcoming or things that you can do in the meantime. So these results that we're sending out statewide are from the localities' July submittals. So as you have noted, probably from a local perspective, VGen is starting to have formal data calls twice a year. So within those data calls, we're able to take these data that you provide, and we're able to do analyses, which we've done. So the data that we've used has been the one from July that we have just called upon. We're going to be doing this again in January of 2017. And we will run these analyses again for you on the GIS side. So we will redo the GIS analysis to see how well data is synchronized from that data call. We want to stress that the results are not necessarily a reflection of the quality that you provide. We know that there's good work being done from the localities. We certainly appreciate collaborations from the state level that we're able to do with your data and you. And also, we just appreciate localities in general because they are the engine that powers statewide data sets. So we want to stress that that's not necessarily a quality of work. And just like anything, when it comes to data and having good quality data, we think that localities will agree that it's better for the Commonwealth for us all to have good quality data. Localities will need to take these results, and you'll need to determine if the inconsistency is a true error or if it's not. So in the case of some of those as we reviewed, they appear to be true errors, but since you all are the ones who are developing the data, who are working with the data daily, only you can determine that. So if you determine, okay, these inconsistencies, they're not true errors, there's a reason behind it, flag those and provide those back to us, and we will skip over those as we run these analyses moving forward. Also, make changes to your database and your ability. We understand there are some localities that have to contract GIS data out and GIS data maintenance out. We know that there are going to be challenges when it comes to making this data better as a whole. So if you are doing most of your GIS data development and data work in-house, and you have the ability to make changes based on the data that we hand you, absolutely make them where you can. But at the same time, if this is one of those areas where you feel like it could be a good opportunity to pursue a grant, by all means, contact one of your ISP regional coordinators, reach out to them, check and see where you may be able to qualify for a specific grant to clean your GIS data up. So yeah, contact VITA staff, contact me, contact your regional coordinator, and then contact VITA in general if you need us. Also, from this, we want to get your feedback and see how worthwhile was this project. How did it work for you from the GIS side, from the provider side of things as a whole? How are these working for you in your operations? That's kind of the idea here. So with that, I think that's it. I just want to close it up. I appreciate you and your time. And if you have any questions, why don't you go ahead and pose them, and I will take them as I can.
I've got a question.
Oh, yeah.
Hi, I've got a question.
Yeah, go ahead.
This is Robin Cummings from Frederick County. I was just wondering if it's possible to get the model that you guys use so we can run it ourselves after we make some of these changes.
Yeah, that's a good question. We've gotten that a lot actually from some localities. The answer to that is yes and maybe. The reason why I said maybe, the reason why is we utilize the GIS Data Reviewer extension, and it is pretty heavily in the GIS analysis. So also we utilize custom data sets that we've generated through this process for the analysis, and other items of interest that are related to schemas from the localities and schemas from us. So there's going to be a caveat there. So if you get the models that we have, I'm about 100% confident everything in there is going to be broken. So with that, if you want to be a sleuth and try to piece it back together, we'll talk offline. But just wanted to throw that out there so you know what would it entail to actually have these working on your end.
Yeah. I mean, I was expecting some tweaking to be sure. I just kind of like to see what it looks like and see if it would be feasible for us to kind of recreate it for our own use.
Yeah, absolutely.
In between.
And, the big one that we keep getting questions about is the fishbone component. So, I think there are out-of-the-box ways to do this, within some of the geoprocessing tools and some of the topological tool sets that are within the ESRI, ArcGIS, out of the box. But ESRI Data Reviewer is what we rely heavily on for this. But in all honesty, to create a fishbone is relatively easy. It requires a little bit of tweaking, and it requires an ArcInfo license, but it's relatively easy to create one. It just requires several steps to be able to piece it together.
Okay, all right. Well, thank you. I'll be in touch about getting the model, maybe.
Sounds great. Mm-hmm. All right. Any other questions?
This is Tracy Bland with Chesapeake Planning. Where am you? Hello?
Yes. Yes.
Okay.
Go ahead.
Where did you say for us to contact to pursue grants?
Okay, so you'll want to reach out to your regional coordinator. In your case, being in Chesapeake, Lyle Hornbaker is going to be your representative to assist you with piecing anything together. So yeah, so any locality in the state, if you're wanting to pursue grants of any kind related to GIS development or anything like this, reach out to your regional coordinator. We have a map on the VITA ISP webpage that shows a listing of all the regional coordinators by their territory that they cover. Okay. Anything else? Any other questions? And, by all means, send me an email if you have any individual questions that you wanted to ask offline. And we'll talk, if need be, about the process.
Hey, Kenny, can you hear me? This is Autumn at the town of Culpeper.
Hey, Autumn, how's it going?
Hey, I tried to send a chat, but my question is, where do we flag the exception? So if it's not a true error, you said there's a point layer, and I'm looking at our analysis, and I'm not sure where I'm supposed to put that.
Okay. So that information is in a zip. It's in a different data set. So we've generated that for the purpose of sharing. So in the case of this, it's just a matter of me getting you in touch with it. It didn't come out with the results, I don't believe, but we'll look into it, and I'll make a note to get back with you, follow up with you about them. But anyone else, any other locality that is needing that, we have the data. We'll put it out online, and we'll reach out to you and get you in contact with that.
Okay, thank you.
You're welcome. Okay, well, that just about wraps it up. We appreciate you all listening in to the webinar, and if you have any questions, by all means, let us know.
Hey,